All right, here we go. Let's get right into it here. Here's what I need you to do. You guys have a piece of graph paper on the second page of your notes. Everyone see it? Okay, we're going to have to flip back and forth here. What I would like you to do right now is make a 3x4 rectangle for me. All right? 3x4 rectangle on that piece of graph paper. So 1, 2, 3, 1, 2, 3, 4. Three by four. And this is what we're going to refer to as our original rectangle. So anytime we want to go back to the original, we're talking about this 3x4. All right, go back to the first page of your notes, and can you fill in the chart for me for the perimeter of that rectangle and the area of that rectangle that you just drew? What's the perimeter and what's the area? So we got perimeter of 14, area of 12, correct? 14 and 12. All right, here's what I want now. Let's start getting a little creative. I want a rectangle now that's similar to the original. Similar to the original. Meaning their sides are in the same ratio. Okay, so I have a 3x4. What do you want me to make now? I want a rectangle that's similar to the original. Oh, Abbott, you're going to have a, what do you got? 6 by 8. All right, let's do a 6 by 8 and call that rectangle number 1. So let's do a 6 by 8 now. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay, perimeter and area. Getting 28 and 48. Good so far? All right, give me another one now. That would be similar. We got 3x4, 6 by 8. What else could we put? All right, you're going to make me do it. What else you want me to put? 13, Charlie, what else you want?
Could you do a 9 by 12?
We could, 9 by 12, yep. And if you guys don't want to draw it, you don't have to. I just wanted you to pick it up here. So we'll do a 9 by 12. So if you have a 9 by 12, go ahead and figure out the perimeter and area of a 9 by 12 rectangle. So you're getting 42 and 108. 42 to 108. We're good there. All right, one more. Can we decrease it a little bit instead of going like 12 by 16? Can we go 1.5 by 2? Is that all right? If I cut it in half, 1.5 by 2 now. Let's do that one for rectangle 3. 1.5 by 2. What's your perimeter and area? One and a half by 2. Seven by 3. All good? All right, I know this is not a good breaking point, but I will be back in like 7-8 minutes. All right. So if you have other stuff to do, we found all these rectangles that were similar to my 3 by 4. Right. So here's what I want to do now is I want to compare their sides, their perimeters, and their areas now, and let's see if a pattern happens. Right. So again, similarity ratio, just to remind you, we haven't talked about that in a couple of units. That's the ratio of the sides. That's the side ratio. All right. So just make sure you understand when you look back what we're finding. That's the area of the sides. So let's go to rectangle 1 to rectangle, the original rectangle. All right. So this was rectangle 1 up here. That was my original rectangle. What's the ratio of their sides? Just pick 2 corresponding sides and tell me what the ratio is right now. 9. What's the ratio of the sides? Okay, but I'm going 1 to the original. So 6 to 3. Let's reduce it a little bit. Everyone's good. 2 to 1, right? 2 to 1. Everyone agree? 6 to 3, 8 to 4. It's a ratio of 2 to 1. All right, now look at their perimeters. 1 to the original. 28 to 14. Anybody want to reduce that for me? 28 to 14. What's that reduced down to? 8?
2 to 1.
Oh, wait a second. We might have something here. Now look at the areas. 48 to 12. 48 to 12. Oh, I hate to break it to you. That's not 2 to 1, but it does reduce down to what, though? Maybe not 2 to 1, but 9? 48 to 12. All you have to do, just type it in your calculator. 48 over 12 as a fraction, and it'll reduce it for you. 4 to 1. All right, let's keep going here. So we establish a pattern. Now let's go to number 2 to the original. I just have to remind myself that was what? My original was what? 3 by 4. What did we pick for this one? 9 by 6. No, we didn't pick 9 by 16. What did we pick?
I think it was 9 by 16.
It was 9 by 16? Yeah, you're right. 9 by 16. All right. Tell me the ratio of the sides then. Give me the ratio of the sides now. 9 by 16 compared to the 3 by 4. Ratio of the sides? 2. 9 to, just pick 2 corresponding sides. A 3 by 4 rectangle and a 9 by 16. Just pick 2 corresponding sides.
Yeah, 3 to 1.
3 to 1 now. There we go. Everyone look at the perimeters now, please. Rectangle 2 to the original. 42 to 14 was the perimeter. 42 to 14. What's the ratio then? What's that break down to? 42 to 14? 11? Oh, I think we are establishing a pattern. If I know the side ratio, I also know something else. Let's go to the areas now. Area 108 to 12. 108 to 12. 13? 9 to 1. All right, we got to figure out something that's going on with the areas, right? And then finally, let's go to rectangle 3 in the original. Remember, rectangle 3 was what? 1.5 by 3? No, by 2. Sorry, 1.5 by 2. All right, give me the side ratio now. I want to go from rectangle 3 to the original. Rectangle 3 to the original. 10? 1/2. 1 to 2. Yep. 1 to 2 was the ratio of the sides. What about the perimeters? Everyone look at your table now. 7 to 14. 7 to 14. 4?
1 to 2.
Whoa, 1 to 2. And then what about the areas, though? What about the areas? 3 to 12. That breaks down into 11. 3 to 12. What's 3 over 12? 1. What's it reduced down to?
0.25.
Oh, go ahead. Do it as a fraction. Get a fraction template. 3 over 12. It'll reduce it for you. There we go. 1, 2, 4. All right. I don't know if you see anything, but definitely there's something there. All right. There is something there. So how do the ratios of the perimeters and the ratio of the areas compare to the similarity ratio? Ready? What do we see here? Similarity ratio. And I'm not going to put anything in between. And then I'll write perimeter over here. Look at your table. Compare the two. Similarity ratio and perimeter ratio. What do we see? Look at your table. What do you notice about the two? 5? They're equal. There you go. If I know the similarity ratio, I'll know the ratio of their perimeters. All right, now we're going to have to dig a little deeper in here, above average kids, because I cannot put an equal sign in for the area ratio. If I put an equal sign there, that will not be true, right? Everyone agrees? 2 to 1, 4 to 1, 3 to 1, 9 to 1, 1 to 2, 1 to 4. So here's where I need you to dig deep. What would I need to do to the similarity ratio to get to the area ratios every time? Same rule. What would I need to do to each of them to get to the area ratio? How do I go from 2 to 1 to 4 to 1, 3 to 1 to 9 to 1? Got something, Abbott?
Square.
Oh, my man, there you go. I'm going to have to square whatever the similarity, everyone right? Square 2 to 1, you get 4 to 1 to get the area ratio. Okay, so that's what I need to do. Square the similarity ratio to get to the area ratio. And now let's officially write it in our theorem now. Let's officially write it. Here we go. Number 1, S1 over S2. I'm just going to let you know S equals similarity ratio. Is the same as P1 over P2. And I guess is what P is going to be equal to. That's my perimeter ratio. And then number 2, here's the second and final thing we just learned. If I know this side ratio, that's not true what I wrote down. Adjust it for me. A is area ratio, but that's not true what I wrote down. Anybody want to adjust it? Well, from what we just talked about right there. That is not true. The side ratio and the area ratio are never the same. How do I adjust it to make them equal to each other? What do I need to do? 8.
Square the side.
There you go. Square each of these to get to the area. Okay. All right, you ready? So do you use these now? And this only occurs if the two figures are similar, which we should be told that they are. For each pair of similar figures, find the ratio of the perimeters and the areas. All right, ready? So first thing I'm going to need is, what's the side ratio here? What's the side ratio of these two figures? Just give me 2 corresponding sides. That's all I need here. What's the side ratio? 3? Side ratio, Spence?
4 over 5.
Good job. 4 over 5. Could he have picked 5 over 4? Yeah, you should have. Order doesn't matter here. But now it will. All right, so what's the ratio of the perimeters then? What's the ratio of the perimeters? My side ratio is 4 to 5. What's my perimeter ratio? 6. Also 4 to 5. Now, hey, I want to make sure we're clear here. Am I saying the perimeter of one is 4 units and the perimeter of the other is 5? No, I'm not. Obviously not. All right. What I'm saying is, if whatever the perimeter of the smaller one is and the larger one, if I put them on top of each other, went to my calculator and reduced it, you know what my calculator would tell me? 4/5. That's what that means. Don't think that the smaller figure has a perimeter of 4 and the larger one of 5. No. Whatever the perimeters are, if you reduce them, they become 4 over 5. All right, and then how about the area ratio? Not 4 to 5. What's the ratio of their areas? 4? What do I need to do to the 4 over 5? Square it. So what's the area ratio?
16 over 25.
There you go. Again, guys, am I saying the ratio of the little one is 16? I'm sorry, the area of the little one's 16 and the area of the bigger one's 25? No, I'm not. I'm just saying whatever those areas are, you divide them and reduce them, it's 16 over 25. All right, here you go. 2. Before I start anything, what's the side ratio? Ooh, you're going to have to do a little work here now, right? What does that 3 match up with? And how can you tell what it matches up with? Put the angles on top of each other. All right, put the congruent angles on top of each other. And what would the 3 match up with in that bigger triangle? So it would be 3 to what? 8 or 5 here. What's the 3 match up with here? Again, put the congruent angles on top of each other. 1. What's the 3 match up with, Ann?
5.
5, yep. And if you need another trick, see how 3's across from this angle that's got 2 arcs. So the matchup has to be across from that angle that's got 2 arcs. All right, let's go down the line here. What about my perimeters now? What's my perimeters? 12. Area, the ratio of the perimeters? What's the side ratio?
3 to 5.
What's the side ratio always equal to?
3 to 5.
3 to 5, the perimeter ratio. Remember, they're always equal to each other. The areas, though, not so much. All right, what's the ratio of my areas here? 5?
9 over 25.
Square them, right? Square the side ratio, you get the area of the ratio of the areas. Questions? All right, I'm skipping to the last problem because of time here, because the last problem is basically everything you're doing over the weekend in the textbook. All right, I got 2 similar rectangles, so let me just get a visual here. I got 2 similar rectangles here. The shorter side of one rectangle is 6 feet. The shorter side of a similar rectangle is 9 feet. The area of the smaller one's 48. What's the area of the larger one? Right? There's my picture. Let's start. What's the ratio of the sides here? I can't start anything unless I know the ratio of the sides. What's the ratio of the sides here? 3. Spence, what's the ratio of the sides? 6 over 9. If you guys want to reduce that, you can. It's not needed. But what am I asked to find in this problem? What am I finding here? 2. Nate, what's it asking me to find?
The area of the larger rectangle.
Area. So if I need area, what's the area ratio then? If the sides are 6 to 9, what's my area ratio then? Because if you're going to ask me to find area, I need the area ratio. What's my area ratio? 8?
A 1 over 8. Sorry,
Yep.
S1 over S2 squared.
So go ahead, square them for me.
36 over 81.
36 over 81. We're all good here. So the ratio of the areas is 36 over 81. Now I match it up with the corresponding area. 48 is the smaller area, so it goes with the smaller number in the ratio. And then I put X for the larger area. I need the area ratio to find the area of the rectangle. Okay? Sides don't do me any good. I need the area ratio before you find me an actual area. And now you guys know, cross multiply, and we're good to go. Okay? We'll fill in any more gaps from the assignment on Monday, but you got to try the assignment for me, though, this weekend so we can fill in those gaps. Please use this problem as a guide over the weekend. Use that problem number 5 as a guide. Behave.